Well, thanks a lot, guys. It's very nice to be here. I'm talking today about the state of Ruby, the state that things are in. So let's get cracking. Well, this is a Ruby. We've all seen a few in our time, right? They're in a pretty good state, I think. There's been a lot happening recently. And today I want to just split things into two areas and then get stuck in. Firstly, I want to talk about some tech, because there's lots of good new tech happening in Ruby these days. There's heaps of stuff happening. We just heard and saw that so much progress is happening in all of the interpreters, particularly in jruby land from Charles. So I want to talk about some tech, and I want to talk about feelings as well, because feelings are important, and the state of Ruby has left me feeling some feelings. So, but first tech. Let's get into tech, because we all know tech, right? So Ruby, this is the date when Ruby first began. This is when Mats started work on it back in '93, on the 24th of Feb. And since then, so much has happened. Like I said, MRI isn't the only one these days. There's jruby, there's rubinius, there's maglev, there's macruby. There's so much going on. But in that last, since then, there's been so much happening, and pretty soon there's an interesting date coming up, which is 20 years later. In fact, in 2 days' time on Sunday, we're hopefully going to see a really big change, which is 2.0, which is going to be great. I'm really excited about 2.0, and it's going to be. I think it's a really interesting release. And to me, the thing that characterizes this release is convention. So this release is around formalizing useful conventions that we've all developed as Rubyists, and it's about finding new solutions for bad conventions that we've all sort of found ourselves using, to get the job done. So what's actually changed in 2.0? Well, I want to talk about three things quickly, three little things, and then I want to talk about three more things in some more detail. So firstly, copy on write. This is going to be a great change. So as most of us will know in Unix land, copy on write is what happens when a process is forked, right? So forking a process is a really cheap operation because the new process gets to share its memory with the old one. And as soon as, excuse me, as soon as any of that data is changed, that's when the kernel will copy into the new process's memory space, and then they'll start using their own separate areas of memory. But until that point, things are shared. And this doesn't work so well with Ruby because its garbage collector touches every object when it does its mark and sweep. So copy on write pretty much has no effect. Every forked Ruby process essentially duplicates its memory footprint. But the garbage collector in 2.0 has been vastly improved. So instead of that mark phase of the mark and sweep being stored on the object these days, or as of 2.0, it's going to be stored separately in like a central list. So the objects themselves aren't going to change during the mark and sweep. So what this is going to mean is that the resident side of all the unicorns, or whatever you use to run your rubies, will stay the same. But the shared size will really increase. And that means that, that the overall footprint is a lot less, because there's a lot less duplication. I was hoping to have some numbers to show you for this, but I can't actually get my the app that I work on in my day job running on 2.0 yet. There's an exception somewhere down inside Rails, and I tried. I thought, well, maybe I'll just cause an exception on Ruby 1.9 as well, and then I'll compare the numbers. But they didn't come out looking right, so I thought I'd leave it. But suffice to say, it's less. Secondly, Unicode strings. This is a good one. So as we know, 1.9 introduced Unicode, introduced encoding on strings. Back before that, on 1.8, strings were just arrays of bytes. It was simple. It was like C. A string was just characters, and that was that. So when we move forward to 1.9, everything suddenly gained an encoding. By default, US ASCII, just text, just a single byte per character. And that's all very well for us English speakers if we want to say hello, but in so many other languages with other character sets, in particular Japanese, where Ruby hails from, if you want to say hello, this is konnichiwa, then no good. You have to annotate your file with a coding statement at the top to say all of the literal strings in this file should be considered to be Unicode, and that's how things work in 1.9. And in 2.0, it's the next step for pushing encodings through the language, right? So encodings now are UTF-8 by default for literal strings. So you can not worry about those coding statements at the top of the file anymore. Everything's just Unicode by default, which is a really nice change. And it's important to note, too, that this just affects literal strings. So if you read from a file into a string, or that sort of thing, that's already Unicode on 1.9, possibly depending on the system you're running on. So yeah, for literals these days, just all Unicode all the time, and done. So thirdly, keyword arguments. I'm really excited about this one. This is going to be great. So this is what I mean when I say that 2.0 is a release about convention. Because keyword arguments are really just a formalization. They're a formalization of the way that we all do it, the way we pass around optional named arguments as a hash tacked onto the end of a method call as that last parameter. The initial commentary around named arguments was kind of negative because people were saying, look, these aren't proper named arguments. They're not like Python ones. You can't just pass any argument by name and so on. And that struck me as being a bit unfair because they're not intended to be, the way I see it, they're not intended to be a full named argument solution. They're quite specific. It's a formalization of how we pass those default arguments. So here's an example. This is just a little simple bit of code I wrote up. So we want to, we've got this little renderer class, and we want to pass in some options. So we tack on a hash as the last argument there. We've got some defaults that we can give just by merging that hash. And this kind of works all right, but it's not great. So on 2.0, things are going to look like this instead. And this is going to be a really nice change. You can see the default has moved up into the definition, and you can refer to them just as an argument, not just looking something up in a hash. They actually coexist with existing default arguments, and they have to be the final argument on the very end. So these are all valid ways of calling that method. You can just call the required argument, or with the default, or with the named, or with both, and they'll all do the right thing. Probably wouldn't recommend using both at once, but it's possible. It's backwards compatible. So what does it look like with real code? Well, this is something that I pulled out of Rails 3.2. This is the first part of the definition of accepts nested attributes for. And so there's quite a bit happening here. There's three things to note. There's the setting of the defaults. I probably should be gesturing at both screens. There's the setting of the defaults. There's extracting the options from the arguments. Because these are splattered arguments, they need to actually be pulled out separately. And then there's asserting that unexpected options won't pass in. And I don't know about you guys, but by the time I get past there, I need a cup of tea and a lie down before I even start on the actual method body, because this is really verbose stuff. This is really involved. And on 2.0, this looks beautiful. So this totally changes. And all three of those things, right? So the pulling the arguments out of the parameters, the setting the defaults, and asserting that the keys, that unexpected keys aren't there, is all taken care of in this one little block. So this is a change that we probably won't be able to use for some time, because we can't start using these args inside Rails until it requires 2.0, which is going to be a long time into the future. But it's something that will probably start to creep in here and there, and I think it's a really good change. So next, refinements. So this is a big one, right? This has been talked about a lot. This is a change that I think is going to be really good. But there's been so much discussion around it and quite a bit of uncertainty around it. So what's the deal with refinements? Well, monkey patching is something that we all know and love, right? We've all patched a few monkeys. We all know what's going on there. It's not great. It doesn't work very well. It seems convenient at the time, but it causes feelings later on. It causes tears and lots of emotion. So back in RubyConf, I think it was 2010 or maybe 11 when Mats was talking about his plans for 2.0. He talked about classboxing. And classboxing was his idea for non-global monkey patching, which was actually first talked about in a paper back in 2003. Mats was planning that this feature would be used for 2.0. Classboxing became refinements when there's sort of little differences between them, but the idea is quite similar. So the way it's going to look is, say we take this bit of code, right? This is a method that I love, collapse. I think this is a great method to throw into array. I monkey patch this on array all the time. And well, no, I don't, but because that's a bad thing to do. But the idea of collapse is that you can filter a list and then remove the thing you filtered by in one step. So one good example of it is using it for something like this. Like you run a Git branch, you split it by lines, and then you collapse it by asterisk. So that means out of all of the branches, pick the one that's active with the asterisk, and then strip off the asterisk. And so the result of this is the active branch. So collapse is a really nice little, concise method. So what it's going to look like in 2.0 is instead of patching things onto this class directly, you throw them inside a module that refines the class. And then this is just a chunk of code that's wrapped up. Refine also is not a keyword. This is just a method call that you pass a block to. And then this refinement called patches, or this module rather called patches, you can then just use in order to get that functionality. And using originally was going to be a statement that was, you could throw it in a module, throw it in a class, and then gain those refinements for the class. But at least as of the second release candidate, which is the most recent release, using only actually works at the top level of a file. So at the moment, using and pulling in refinements is a per file thing. This is an example of what probably eventually will be possible. Just define a refinement and then define a little class in which you use it. And this is a great way of wrapping up functionality, but it's not working yet. I imagine that it will pretty soon. So I've got a little demo here. I need to turn on my mirroring so I can use the keyboard. So this is that same class. If I turn that off and run things, then we can see, so undefined method collapse. So this whole block of code here is really just, it's not affecting anything right now. But if we turn things on, then great, it's printing out master. And you'll notice there's actually a warning here. So this is, refinements are experimental, and yeah. So they've been very clear about don't go too nuts on this stuff yet. It's still sort of the kinks are being worked out. My keynote has disappeared. Oh no, great. And disappeared again. This mirroring is tricky stuff. There it is, beautiful. So I've got one more example to show. If I flick that over again. So this is just another little example of how the refinement can be pulled in easily from another file. So this is the kind of way that I think we're going to see things to really start to get nice and neat. Is where that stuff now is not even defined in the same file. It's away in a gem somewhere, away in some other completely separate part of our app. We can pull in that refinement, and if I turn off the call over in that file and run, so then I can instead here say using patches, and so that didn't work. So that's my first demo of the day that has not gone to plan. Yeah, so I'm not going to look at why now because that'll be down the rabbit hole. But this is the idea. You can pull something in from elsewhere and keep it really quite contained in this little scope. So there's a feature of refinements that was originally going to make it in, but it looks like it hasn't. And that is called local rebinding. So what this is about the scoping of whether a refinement is active and not. And this stuff is really complex. There's a lot of trade-offs because the thing that's tricky about these refinements is the point of them. And Yehuda Katz wrote a great piece on refinements in practice. And he was saying that the point of refinements is to wrap up scope, right? Just to keep it local. And if you allow rebinding, so what rebinding is in this case is it's very tricky to explain, but it's rebinding in this case is where if you say pass a block and you eval the block in the context of a rebinding, then if you have local rebinding active, then the refinements are active on that block, on a piece of code that wasn't actually defined statically against the rebindings, but then is run against them, the rebindings would be active. And local rebinding actually kind of breaks that localization of refinements. It kind of breaks the goal because it means that code that wasn't written with the refinements in mind might end up running against them. So the important thing about them, about refinements, and I think this is a really good move, is that they're lexically scoped. They're statically scoped. These are the same things pretty much. And at first it looked like they might be pseudo-lexically scoped. That's a hard thing to say. But it looks like it may actually have turned out to be strict. It's been tricky to find out exactly why. Charles, if you're here, I'm sure you can correct me if I'm wrong. Charles has been really instrumental in the process of getting these refinements to the state they are. But it seems that they're actually going to be statically scoped, which means that only code that was actually statically defined against that using statement will run against the refinement. And this is a really good change. This is a really good decision, I think. It does mean that there are some surprising effects, but I think it's a good move. So, as an example, I've done up another little example here. So this is my little dictionary class I've made, and the word list is just opening a file, right? So that's just returning an open file handle to my dictionary on the system. And then long words is just getting the word list and finding the longest ones in. So this code down here is just going to tell me the 10 longest words. So if I run that, I have never seen any of these words before. So that's just giving me a list of words, right? So what if I want to change this class in some way? Maybe I want to run against the names list instead, right? So these are the longest names in the name list on the system. So, and I only found this was here a few days ago. It's great. Nice to see some Douglas Adams in there. So if I just undo that change, I'll just go back to words. If instead I want to refine this, right? So I'm going to comment out this call. Say instead we want to refine that class to change the word list. So this is, in some other context, we want to use the class, we want to use this same class, but change what the word list points to. Well, it turns out that we can't do that, because if we run, this is still printing out the words. This isn't printing out proper names. This is just printing out the word list from above. And the reason for that is that what we've done is we've refined, in this scope, we've refined using that dictionary. So in this scope here, any calls to this dictionary object down here will be using the refinements. We haven't refined long words, so that just goes up to the original class. And in this context up here, when we call word list, the refinements aren't active. So up here, the original word list method is being called. And this kind of seems a little bit surprising. It seems like from our intent down here, what we'd want is for that method to be refined. But the important thing to realize is that this is all our code in one file. And when you're calling into a class, you're calling into someone else's code. And to change the intent of what someone else's code has been doing is a different thing altogether, because if you think about some gem that you've released, for someone to be enabling refinements and suddenly your code in your gem is calling stuff you didn't expect, well, it's kind of like monkey patching all over again. So this static scoping, this lexical scoping, there are definite limitations to it. But I think that once we get the feel for it, it will really start to solve those monkey patching problems. I think it's definitely the right way forwards. So I think my phone is, oh, someone tweeted me and it switched away from my presenter. Great. Should have turned on airplane mode. So the next thing I want to talk about is enumerable lazy. This is a great change too. Charles mentioned it just before. This is going to be a really nice change because it means that we can make things declarative that weren't before. So everyone knows like an infinite list, right? In maths terms, an infinite list is just, this is all the natural numbers. And we can say this in Ruby too. We can say, just give me a list, start at 1 and go up to infinity. And also, this is not great because this is the integer 1 up to the float infinity. And there's, as far as I know, no other way to express this in Ruby. And I was sort of thinking, does it really have to be this way? And Ruby sort of looked back at me in that way that it does and said, well, this is just the way it's going to be. But it doesn't. Moving along, it's okay. I'm okay with that. This is an infinite list, right? This is all our natural numbers. So let's call it natural numbers. This, if we try and evaluate it on 1.9, this is not going to go so well. This is just going to, the computer isn't going to be happy. It's going to use up all the memory and never return. But we can make it lazy. And if we do that, then we can start operating on it in really interesting ways. So say we want to select out of the natural numbers all of them that are prime. And so this is just saying, for each number from 2 up to its square root, if anything is a factor of it, then it's not prime. So it's saying, for all of those factors, is there a remainder when we try and divide them? So if we want to just call that primes, that too is an infinite list because there's infinitely many primes. There's just less infinite than the naturals. But this is great. We've got an infinite list, and we're filtering it into another infinite list. And Ruby doesn't mind. It's all, it's great. Everything's working well. And down at the bottom, we can just say, OK, primes, just give me the first 10. And that will then lazily filter back through this infinite pipelined list and just pull back those first 10 elements. And the select, will sometimes cause 5 or 6 to be pulled through from the each before it pops one back. But all the laziness kind of just falls out, and it just works. So at this point here, we don't actually have data yet. This is still an enumerable object. And we can just call .force on the end to force it to evaluate, which is actually just an alias for 2a on the end. So I've just got a couple of quick little demos for this. Here's that same code over here. If I take that off, I don't actually know how to tell Sublime to stop running code, so I'm not going to do that. But if we run this, nothing up my sleeve, it works. So lazy totally works. It's great. There's one more little demo I've got. I just want to quickly find out which file it was. I've got it in my notes here. Excellent. So this is one more example. I really like using the dictionary for examples because it's great. Like it's a really long list, and it's data that is it's real world sort of useful data. So this is the way that you can define a custom enumerator. So as well as enumerating just pure arrays and things, you can also loop over whatever you like. So with this example here, say we just return that file and say, in fact, I think we'll just say the file. So say we want to select words that are over a certain length and take the first one. So if we run this, that'll run fine. We get a list of words back, and it ran in 3 seconds. But say we want to do this a few more times to see how long it'll actually take. So that's starting to take a little longer, right? That takes a second to open the file 10 times and read. If we make it lazy, then suddenly it's really, really fast again. So what lazy lines is just a little class that I monkey patched onto I/O. What it's doing is just creating an enumerator, passing in itself, which is the open file, and saying, each time you need an object, just yield this block, and then I'm just sort of pushing it onto that list. So this is kind of the trivial case for a custom enumerator. But these can be defined to do whatever you like. So there should be some really nice ways we can use these. This really simply wraps up the process of reading that large file into something that's lazy. So after looking at that laziness, I want to just jump back onto refinements for a moment and just show one more little thing, which I found really interesting. So when I said they're experimental, there's definitely some kinks that aren't ironed out yet. And this is one of them. So I'm just going to flick back onto my terminal and show you this code. So this is kind of the last two examples I had smooshed together. So this is the same prime number logic wrapped up in a refinement on fixnum. So this is just patching a method onto fixnum called prime that we can use down here to say, all right, just take all the natural numbers, select the ones that are prime, and give me the first 10. So That's going to work as we expect because we've mixed in our refinement here. Everything's looking good. But what if we want to use symbol to proc notation? So if we want to do that, then suddenly things don't look so good anymore. The error up here is no superclass method prime. So if we change the name of this method to something that's definitely not defined, then it's not quite the same error. In this case, it's just undefined method, right? So there's definitely, Ruby can definitely tell that refinement is active somewhere. But for some reason, just changing to simple to proc notation has stopped us from calling it. And the reason for that is that suddenly the place that we're calling prime isn't in our code anymore. So what this means is the definition of toProc on symbol is actually the point where the prime method is being sent to that fixed num. And it kind of makes sense, but it's also really surprising because we expect to be able to use this kind of notation. So this is sort of another example of how refinements, they're really getting there, but they don't quite feel right yet. So I wouldn't be surprised if simple to proc just became a special case with refinements, because I think that that's a case where there's very clear intent, and despite the fact that the actual message is being sent somewhere else, and so the refinement isn't active, we'll see what happens. So so lastly, I want to talk about module prepend. So this is a great one too. In the same vein as keyword arguments, module prepend is a formalization. So everyone's heard of alias method chain, right? Alias method chain is a way that was used in Rails a lot to patch functionality on after the fact or to patch functionality around something. Gems like New Relic and Haml use a technique like this, where New Relic will say, right, I want you to do the work that you were going to do, but I'm going to wrap my benchmarker and my profile around the method so I can measure how long it took. And the same with Haml, it'll say, render the view as you were going to, but I'm going to wrap my renderer around it so that I can catch references to Haml code and render them along with it, and so on. So prepend is much like include, in that when you include a module, then you can override its methods and you can call them and so on. But when you prepend a module, it can override your methods. So the precedence is different. One good example of this is comparable, right? So comparable is a module you can include, and if you define the UFO operator, then suddenly you get all of this free functionality from comparable. You get like less than, greater than, you get sorting, you get anything that involves comparison just from defining this one operator. And the reason that works is that that functionality gets pulled in and then called as it needs to be on the superclass. So super is kind of the thing that makes all this including and prepending work. So what's actually happening when we call super? Well, it's to do with the ancestry of the object. So if we take a string that has had comparable included into it, then this is what the tree looks like. So firstly, you have the class itself, and then you have things that have been included into it. So in this context, comparable. And then back from there, you have the other objects that it inherited from. So object all the way back to basic object. And the difference with prepend is that when the thing that you've included, or that you've prepended rather, is inserted into that ancestry, it's inserted not behind the object that included it or that prepended it, but in front of it. So I'll just give you a quick look at that now. So I've just done up another little simple example here. I've got a little template class up here that renders some ERB, and I have a renderer that says that uses the old technique using alias method chain. So what I want to do is that New Relic style example of saying, do the normal work you were going to do, but I'm going to wrap my profiler around the outside and measure how long it took. So if we run this, then we'll see. Well, in fact, I've got the wrong one uncommented. So if we include this class and run it, we can see the profiler is printing out its its message here, and then the actual output is being printed underneath. So that, that message that it's printing is just here. So the idea with render profiler is, we're wrapping around the method, we're aliasing everything into place, and then we're calling the original method here. But calling the original method in Ruby terms is actually just calling super. That's what we want to do when we're inheriting. So the way that we want to do this instead is, instead of this class having to go through all of this boilerplate, all of this, use this pattern, what we really want to do is just do something that looks more like normal inheritance. So in this case, we don't need to have render with profiling and render without profiling. We just define a render method. And then at the right time, we just call super. So it's kind of like render profiler is subclassing the original class. And if we run this, it will work. But the reason for that is that, that this method actually isn't being called anymore because the order is wrong. So if we instead prepend it, then there it is again. So in this case, the super call is calling back down that ancestry and actually calling the original method. So I'll show you what's actually happening inside IRB here. If I just load that example up. Then if we go, should I call it renderer? Oh no, I call it template. So if we say template.ancestors, then we can see that the render profiler is actually ahead of the class itself in the ancestry. And this means that, that these prepended modules actually receive all the method calls to the object. And then it's only if that prepended module doesn't respond that the calls filter back through to the object itself. And similarly, the calls to super, when they call back down that tree, because the super call is basically saying just punt it to the next thing in this list, that they get passed back to the class itself. So that's kind of a wrap of the stuff that I'm excited about in 2.0. There's some really good stuff in there, and like I said, it's all about convention. It's about formalizing and pulling things back into the language that we've sort of found becoming patterns over the last little while. So next, well, my phone is not connected. Next, I want to talk about feelings, and this is a hard one, right? This is sort of a lot less concrete. Things have been, it's the vibe of the thing. Ruby's been an interesting thing to work with recently, and I think that a little bit of introspection every now and then is a good thing. So we saw yesterday afternoon, and well, a couple of times yesterday, -1 was mentioned. Maths is nice, and so we are nice. And I really, really like this this mentality. I think it's just a lovely thing. And we saw Y's documentary yesterday, which was really nice. And I remember getting into Ruby originally kind of because of Y's poignant guide. I don't think I've quite learnt Ruby because of the guide, but I certainly got excited about it because of it. It resonated with me. And I think that I was sort of starting to write this part of my talk, and I was feeling a bit ambivalent. I was thinking, I don't really know what it is that I'm hesitating about, but something sort of feels a little odd. And I started thinking about perceptions. I was thinking about perceptions from within and like the way that us Rubyists think of ourselves. And I was thinking that perhaps there's like a bit of a perception that -1 in some ways isn't what it used to be. Maybe it's kind of, maybe as Ruby's grown, it's kind of it's maybe faded a bit, or maybe we feel like it's faded a bit, or perhaps like a feeling that our priorities aren't quite right. And so introspection, I started thinking, well, maybe we should be looking at, looking out as well. And so I Googled, what is the opposite of introspection, because I didn't know. And I got this page, which said extrospection, which I was kind of skeptical of. But I wanted to show you, because of this thing down at the bottom here, what is another word for the word word, which I really liked. And then this guy replied and said, no, in English, word is the word for word. So I thought that's really helpful. And I was sort of thinking about this, and it was like, no, hang on, I'm trying to do a Ruby talk here. It's so easy to get distracted with these things. But then I started thinking, so extrospection, I don't know if that's the word. I started thinking about reputation as well, and sort of the things that we're famous or maybe infamous for. And the one that came to mind is that, I don't know if it's warranted, but we have a reputation for being cavalier, right? We have a reputation for glitz over substance, and comp-sci be damned, just do it the way that is cool or the way that looks good. You know, whether this is warranted or not, this is perhaps how some think of us, or perhaps just how we think some think of us. And I think the reason that I was feeling a bit ambivalent is because maybe there's a small kernel of truth in there somewhere. Maybe we are a bit cavalier sometimes. Maybe we do sort of throw rigor out the window sometimes. And it got me thinking about this great post that I read by Regenwald. This is well worth looking up. It's called Optimism, and it's this really nice piece that Regenwald wrote about optimism as a programmer and optimism as just a person, and the way that it lets you deal with people in a really different way. And the one thing that I wanted to take from this, I'm not trying to say, let's all just become optimists and then the whole thing will be solved. The one thing I want to take from it is this really nice way you have thinking about interactions with people, of making them impersonal, and not in a bad sense, but taking things impersonally, temporarily and specifically, as opposed to taking things personally, permanently and generally. And I think that this, it's well worth reading his post because he'll do it much better, more justice than I can. But I think it's sort of worth thinking about the way that we interact and the way that these things play out. You know, like I see people on Twitter saying, oh, the JavaScript guys are trying to reinvent comp-sci, and then suddenly, you know, apparently us rubyists are doing everything wrong as well. And you know, it seems like there's all of this butting of heads. And I think that it's really important to remember that heads probably aren't butting as much as we think they are. That people don't actually really oppose each other diametrically. That really what it comes down to is priorities. So I think when it seems that we're disagreeing sometimes, it's actually that we're agreeing. It's just that we have differences in the orders of things that we prioritize. I think, you know, so many people have talked about, you know, there's been the Ruby gems hacks and the Rails hacks and all that stuff. And there's been so much said about it, and everyone has been talking in hindsight and saying, well, of course it was because of this thing, of course it was this. And, you know, there's probably some truth in there somewhere. And I do also enjoy the funny stuff that comes out of it. I really liked this. This I thought was just the best. But I think it really, to me, it comes down to priorities and just, you know, which things we happen to put first. We probably agree on most of the things in the list, like, you know, security and performance and rigor and shipping things fast and pleasing the client. It's just about, you know, what order we happen to place them in. And so in that context, I like to think about it as being goals and constraints. So we all like performance and we all like elegance in code. It's just a matter of which one's a constraint and which one's a goal. We all like hitting deadlines. Oh, I'm wrapping up.
Yeah.
I thought that was 5 minutes. Well, I'm going to push right forward here and say it's all about empathy, because sometimes we look at others' code and we say, what the hell is this? I don't understand. Oh my God, this is the worst thing I've ever seen. I never want to program again. But if we can have a little more empathy, understand where people have come from, maybe we'll get some rigor as well. But it's really more about empathy. Thanks very much.
Thank you.